Hi, welcome to Provoke Your Physics channel. Today we are going to discuss about the how to find the magnetic induction due to a circular coil carrying current using Biot Savert law. Actually, based on the Biot Savert law, we discussed in the previous videos what is actually Biot Savert law and how we can measure the magnetic induction due to infinite long straight wire. இது வந்து நம்ம லாஸ்ட் கிளாஸ்ல வந்து பார்த்துருப்போம். இப்போ வந்து சர்க்குலர் காயில் கேரியிங் கரண்ட்ல how I can measure the magnetic induction. Consider it is a circular coil carrying current. For this, we have to be very clear with the direction as well as the dimension. So let us consider a three-dimensional path. Three-dimensional path means take x and y and z. So let us consider the object. The coil will be located in the xz plane, which will be in which it consider it carry the current of I. The current will be moving in this direction. In which I am just considering a current element dl. So IDL will be the current element. Last video itself I told you what is actually the current element. Current element is nothing but the wire with a certain length in which we are taking the direction of the current with that length, the product of current and the length of the wire. And it's actually Biot Savert law, that is dB vector is equal to mu naught by 4 pi into IDL vector cross R vector divided by R cube அப்படின்னு சொல்லி நம்ம படிச்சிருப்போம். In which all the three are constants. So ideal vector cross R vector. So it is simplifying the vector product. If the current will be moving in the direction of x and z, definitely the magnetic induction will be acting on the y axis or y direction. So which will be mutually perpendicular to the all the three. So and when I simplifying the Biot Savert law, I have just taken dB will be equal to mu naught by 4 pi, IDL sin theta, divided by R square. If I am writing in the magnitude, so here the theta will be equal to 90 degree. So I will get dB will be equal to mu naught by 4 pi. Then IDL by R square. This is what the magnetic induction. But here I can choose the two current element, from one side on the right and one side one on the left. So both will be contributing the magnetic induction. Suppose if the radius of the circular ring will be having the R, from the center to the point, Z, and this is the point where I am going to measure the magnetic induction. And from this point to here, the current element, let me choose the distance R அப்படின்னு சொல்லி வச்சுக்குவோம். நல்லா கவனிச்சுங்க. Based on this, we are going to measure the magnetic induction at the point, in the point P. And I told you it has two combination. One is from the left and another one is from the right. Both will be contributing the magnetic induction there. One will be along this side and another will be along this side. And suppose this will be the angle phi. This will be the angle phi in சொல்லி வச்சுக்குவோம். So here this angle, and this angle will be similar. Because remember this coil will be placed in the xz plane and we are measuring the magnetic induction at the point on along the y axis. So this angle will be the same. So here this will contribute the dB. That is, so this is actually the resultant dB. Similarly, even this is also taking the resultant dB. I can resolve this into two components. One is dB cos phi and this will be dB sin phi. dB sin phi. Similarly, here I can just take dB cos phi and again, so this will be dB sin phi. So automatically, which component will get cancel? dB cos alpha will get cancelled. only dB sin alpha will be contributing magnetic induction there. Okay, so I can just write dB will be equal to, okay, mu naught by 4 pi, then I dl by r square, okay, into sin phi. Now in this diagram I am going to measure what is sin phi. Okay, see, this is angle and this is right angle, so this will be adjacent side and this will be opposite side. So I may know that sin phi will be equal to, okay, sin phi is equal to, okay, so opposite side, that is r, divided by hypotenuse, that is r. Okay, so dB there is equal to mu naught by 4 pi into I dl divided by r square into sin phi. Sin phi I told you that is capital R divided by r. So this will become, okay, mu naught by 4 pi into I dl, okay, divided by r square into, instead of sin phi I can just write r divided by r. Okay, so I will get mu naught by 4 pi then I dl divided by r cube into r. Okay, this is what the thing I have got. See, now we are considering the small current element. Because of the small current element, how much the magnetic induction we have, this is what we have measured. But our aim is to measure the entire magnetic induction. Okay, in order to measure the entire magnetic induction, okay, I am going to integrate that is dB is equal to, here the variable is dB, dl, all the others are constant. So I am just taking mu naught by 4 pi, then I, okay, into r divided by r cube into integration of dl. If I integrate dl, that is nothing but the entire circumference. So this will become, okay, mu naught by 4 pi into I into r into 2 pi r, that is circumference of the circle, divided by r cube. Okay, so I can cancel 2 here, 2, 1 pi, okay, r, we will get r. Take the value of small r is equal to square root of r square plus z square. Okay, so when I am substituting instead of r square, square root of r square plus z square, okay, what I will get? So what I got, dB is equal to mu naught by 4 pi into I into r square divided by, okay, so actually we got dB is equal to mu naught I into r square, capital R square, divided by 2 into r cube. I told you small r is equal to this. So when I substitute, I will get mu naught by 2 into, okay, r square plus z square whole to the power 3 by 2 into I into r square. What is this? This is the magnetic induction, okay, for the circular coil carrying current, okay, at the distance z from the center. Suppose if I want to measure what would be the magnetic induction at the center of the circle. So over the center of the circle, I have to consider that z is equal to 0. So when z is equal to 0, that is at center of the circle, okay, so this will become 0. So I will get r cube. Already r square will be there at the top. So B will be equal to, okay, mu naught I into r square divided by 2 into r cube. Okay, so I can cancel r square and cube. So finally I will get, okay, mu naught I by 2r. If it contains n number of turns, okay, the magnetic induction at the center of the circular coil carrying current B is equal to mu naught n I by 2r. Okay, so this is a magnetic induction. Okay, it's a very important question. Okay, based on this we can measure so many numerical. Okay, it is very important to both IIT JEE type questions and also the NEET based questions. Thank you.